All right, ladies and gentlemen, this is called segment lengths in circles. This is section 10.6 of your book, part 1. It's a 1 day lesson, but we're separating it into 2 days because I want to teach you the formulas and patterns first for segment lengths in circles, and then tomorrow we'll start doing some word problems. So basically today you're going to calculate and solve lengths of segments created by tangents, chords, and secants. All right? So that's the title. Here we go. Alright, first set of segments we're going to talk about are chord segments. These are going to be inside the circle because chords are inside the circle. Kind of makes sense. These are not angles we're looking at. These are segments. So draw this diagram. You'll notice that we have 4 segments. Well, 4 pieces of the segment part. So that made no sense. Just look at the fingertip. Here we go. There's 1 segment, there's 2, there's 3, and there's 4. Obviously, we've got 5 and 6 when we combine the entire lengths of the chord. But what I meant was we're going to just look at the 4 pieces created. And then from there, we can answer any question we want. So after you draw this diagram, let's label these with these letters, A, B, C, and D. Notice where they are. I did that on purpose. Let me explain. A, B, and C, and D all have a proportional relationship. Here's the proportion. A over C equals D over B. One way you can look at it is that if I kind of split this up, this circle, where the chords intersect, if I kind of draw a line kind of through the middle, the intersection, it kind of splits up into 2 halves, right? The left side, the right side. And that's your proportion in a nutshell. Because proportions work this way, you can actually split it up the other way too. I can go sideways. And now I can do A over D equals C over B. Again, it doesn't really matter which way you do it as long as you split them up into equal halves. Right? So the biggest mistake I find is that kids copy the letters and then they write the proportion in order of the letters. So they'll go A over B equals C over D. No, you're not going to do that. All right? So either use this visual line technique or memorize this formula. Either way, you're going to be fine if you do that. So let's clear and move on to the next point. The next point is this. Oops. There we go. Keep A and B on the same line and C. It's not popping up correct. Keep A and B on the same line and C and D on the same line. It's always got to be that way. So A to B and then C to D. A and C must start on the same side. So if A is on the left, C is on the left. If A is on the right, C is on the right. And so on and so forth. I hope you get the point. These are how you find lengths of inside segments. What we're going to do is a practice problem. So get ready in 3, and 2, and now. Practice. Go ahead and draw the same diagram, or you can just write on top of it. You can write or label right on top of your original diagram. We're just going to fill it up with expressions. I'm giving you the hardest stuff first because I'm not going to be here, and I want to show you how to do the hard stuff. That way the easy stuff is a no-brainer. So here we go. We're going to label these with A and B and C and D. So A is going to be right where the x plus 2 is. And let's use a different color here. Let's use yellow. So A is going to be x plus 2, B is going to be on the same line or the same chord, C is going to be our x, and D is going to be our x plus 4. Proportion says A over C, so x plus 2 over x equals D over B, x plus 4 over x plus 1. If you don't see that, if you're still wondering where is he getting this, well, just draw it down the middle. And there you go, you got your 2 sides, the top A and the top D, bottom C, bottom B. Alright, what we're going to do is cross multiply these. So let's put some parentheses around this, helping you remember that you're going to have to do some distributive property. So this is the first one is going to be this one. So I'm going to put x plus 2 and x plus 1 multiplied together. This is just FOIL, if you learned it that way, or double distributive, once and twice. And the second problem is going to be these two linked together. That's going to be x times quantity x plus 4. Again, distributive property. Once. There we go. So, if you don't remember FOIL, it's first, outside, inside, last. I'm just going to, for the sake of time, simplify as I go. So this is x squared. You're going to get 1x on the outside, and on the inside you're going to get 2x. So add that up. That's a 3x plus 2 equals x squared plus 4x. Okay, lo and behold, I think our x squareds are going to cancel out, right? Because you're going to subtract them like this, and then all of a sudden, yay, they're gone. So you don't have to deal with squareds anymore. So now you're just going to move your negative 3x to the other, move the 3x by using the opposite. Go to the other side. Let's get rid of that positive symbol. So x equals a nice 2. Now, we've answered our question because I didn't ask any others. If you had to go and find the different segment lengths or the chord lengths, you would just plug into wherever you see your x, and that's how you would solve this. All right. So these are the hardest kind because they're all expressions. They're not just nice little numbers like 5, 7, 8, and 2. All right. I was going to ask any questions, but obviously I'm not here. All right. Moving on. 3, 2, and 1. Next type of problem. We've got two secants. Draw this diagram. Two secants. So you got a circle, and two secants are starting from the same point outside the circle or external from the circle. Because they're outside the circle and they start from the same point outside the circle, they have a proportional relationship also. So let's label this. Again, we have letters A, B, and C, D. Again, A, B are on the same secant, and C, D are on the same secant. Notice where A is. A is on the outside portion of the secant, and C is also on the outside portion. This is the order that you need to write it in. Okay, it's just easier this way. Let's just keep it a simple system. So what's the proportion? Here's the pattern. A over C plus D equals C over A plus B. If you're not really understanding what this is saying, it's saying that this little segment here, A, is over C plus D, and the entire length of the secant up till the end of the circle is proportional, is equal to the C right here over your A plus B secant. And that's all you have to do. All right, so we're going to plug them in and we're going to solve. Again, this is just a reminder. You don't have to write it a second time. A, B on the same line always, okay, and C, D on the same line with A and C outside the circle. All right, that's just kind of the simple way to remember. Let's move on and do a practice problem. Again, you can just write these expressions right onto the problem you just drew, or you can draw a completely brand new one. Either way, it's up to you. So again, here are your expressions: 3x plus 1, x plus 2, x minus 1. All right, this is going to get pretty messy, so give yourself a lot of room. All right, we're going to label this A, B on the same secant. So A is 3, B is x plus 2, C is x plus 1, D is x minus 1. So let's set this up. It's going to be A over C plus D. A is 3 over C plus D. So we're going to add these two together. Okay, so let's just add in our head right now. X plus x is 2x. And 1 minus 1 is 0. So that's awesome. It's 3 over 2x. And then the next portion is going to be C, so x plus 1, all over A plus B. So we're going to add these two together. So we don't have to add anything to the x, so it's just x plus 5. Alright, so let's cross multiply or use cross products going this way. Right? So the first one I'm going to do is here, so that's 3 times quantity x plus 5. I'm sure some of you can do that in your head automatically. And then 2x times quantity x plus 1. Alright, distributive property, here we go. 3x plus 15 is going to equal, distributive property again, 2x squared plus 2x. Looks like we're going to have to use some factoring skills here because we have an x squared term with no other x squareds to cancel it out. So because we need to keep a positive a term, or ax squared, let's go ahead and move the 3x and the 15 over. So we're going to move it over and move it over. So that's going to be 2x squared. We're going to subtract the 3x as it comes over, so minus x, and then 15 is also going to become negative as well, right, as you move it over to the right, and equals 0. Let's factor this. If you don't remember how to factor, there's multiple ways. You can use the diamond box, whatever. I use guess and check. That's where I know that I'm going to get to parentheses. So the product of 2x squared has to be 2x times x. There's no other way to do that. The product of 15, for me, is going to be either 1 times 15 or 3 times 5. So let's test them out. If I put the 5 here and the 3 here, when I multiply the inside and outside, that's going to be 10x and 3x. That is not going to make a negative 1x, which is what I need to match to make, right? 10 and 3 cannot make a negative 1. So obviously those are not my numbers. Now some of you might see a pattern. Well, if I switch the 5 and the 3, right? Go back and try multiplying the middle two terms and the outside two terms, or the insides and the outsides. That's 6x, that's 5x. I can get a negative 1x, right? I can. In order to do that, one of these has to be negative. To get a negative 1, our 6 needs to be negative. Therefore, the line that I drew the negative 6 on that 3 needs to be negative, which means this has to be positive. So I'm done. I found my factors. If you use your diamond box, you have to multiply 2x squared and negative 15, and you draw your x and yada, yada, yada. If you have questions about that, see me tomorrow. Anyway, we're going to erase, or I'm going to erase this part right here just because I need space to work. So we found the factors, and now let's go out and solve this. 2x plus 5 equals 0, and x plus x minus 3 equals 0. So x equals negative 5 over 2, or x equals 3. Now, one of these is extraneous, and here's how I know. If I have a negative fraction, that doesn't always mean it's extraneous, except for right here, if I take away another 1 from another negative, I'm going to get a bigger negative. So obviously, this is not going to work, so don't use both. So x equals 3. Oops. So, I mean, good strategy is to always keep the positive number, but you always want to test it, right? That's what you learned with extraneous solutions. So x equals 3, that means we can go back and plug them into here, here, and here, and we should be able to find this. Anyway, again, this is the hard type. If I just use numbers like 3, 5, 7, and x, then it would be a lot easier. I'm going to move on in about 3, 2, and 1. Secant and tangent lines. What does that look like? Well, one of them is a secant. One of them is a tangent. Here's your tangent down at the bottom here. The reason why it's not extended out all the way is because once we extend, like I'll draw it, once we extend that tangent line all the way, right, if we drew it further, this part is unusable. It's going to go forever. We don't know what the length is going to be because the circle doesn't, cut it off, so to speak. Whereas these portions right here, they are, finite. They are cut off. They are separated. Whereas this one, we don't know. So that's unusable. We don't really care about it at this point. So don't even worry about it. Right? Let's just focus on this diagram. Let's label this A's and B's and C's. This time there's no D's. All right? And that's because there's only 3 parts. So we only use the letter D if there's 4 parts. So this one's actually quite easy. It resembles the last one we just did. The proportion is A over C equals C over A plus B. And so that means we're going to use this C term twice in the problem. So you're always going to get a nice little C squared when you cross multiply here. You're always going to distribute A with A and A to B right here. So again, keep A and B on the same line. C by itself, you don't have to write it down again. It's just something you always have to keep in the back of your head. All right, again, A and C are on the outside here. So let's move on and finish our second to last problem. Here we go. Draw the same diagram or right on top of the one you just drew, 16 with the 24 and x. This is a little easier. I wanted to show you what an easy one would look like. You've seen 2 kind of a little bit difficult ones in terms of your expressions. Here's an easy one, right? So let's label this. A is going to be your 16, C is going to be 24. Remember, A, B are always on the same segment or same secant. Same secant or chord. So A over C, so 16 over 24. Equals C, 24, over A plus B. A plus B is x plus 16. And I didn't write it as 16 plus x because I just like keeping my variables first. That's just kind of standard the way it is, but you don't have to. But it just makes life easier. So that's going to be 16 times quantity x plus 16, and that's going to be equal to 24 squared. Now, this is early in the morning right now, so I'm just going to multiply this. So 576. All right, so 16x plus 256 equals 576. Let's subtract. This is an easy problem, right? We're just doing a 2-step equation. So solve your work. 16x equals 320. X does go into 32 twice. We have a leftover 0 remaining, so x equals a nice 20. And I don't think we have to do anything else, but if we did, we could always add to this 16, find the entire length of the secant, or blah, 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 whatever the question asks. So just make sure you read the question once you solve for x. All right. We're moving on to our last problem. This is a bit of a challenge, so pay attention, and hopefully you understand by the time I'm done. This is gone at about 3, 2, and 1. All right, challenge problem. Go ahead and draw this diagram. Right. What it is, it's a right triangle. Because we have a tangent segment to our circle where we have this right angle, we know this is a radius. Well, now the radius goes all the way to the opposite end, so this has to be a diameter, right? You cannot have a right angle form with the tangent segment to a circle unless it is the radius, right? That's one of the theorems we learned. So we've got a diameter, we've got a secant, and we've got a tangent. We haven't learned about the diameter yet, and we don't really have to learn about it in terms of this problem. We just have to use it later. So forget about this diameter for now. Let's just focus on our secant and our tangent. So go ahead and label it this way. What we're going to focus on is our 4, 8, and x. So the 4 is our A, 8 is B, and x is C. Again, we'll focus on y later to find the length of y in a bit. So formula says 4 over x equals x over 8. Relatively easy problem. So we're going to get x squared equals 32. So now, before you actually take the radical and simplify, let's just keep it. And here's why. I see a right triangle here. If this is a right triangle, that means I can use either trig functions or Pythagorean theorem, blah, 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 blah. I just found what x equaled, or x squared equaled. X squared is 32. I can get the hypotenuse squared easy, 12 squared, and then now I can set up y squared. So let's use Pythagorean theorem. A squared plus b squared equals c squared. Let's label a as my short side, which appears to be x. So x squared is going to be 32. I already got that. So 32. My b squared is my y, the diameter of the circle, so y squared. And c squared is hypotenuse, which is 4 plus 8, 12. 12 squared is 144. So we have our work set up for us. Minus 32, minus 32. Y squared is 112. Did I subtract right? Yeah, 112. So now we have to go ahead and simplify our radicals. So this is going to be simplify. That's going to be 16 times 2. So that's going to be x equal to 4 radical 2. And we wouldn't use negative values here because it wouldn't make sense, right? We can't have negative lengths. The second one, 112. This one I don't know off the top of my head. So I'm just going to divide by 2. Why not, right? When in doubt, just make it easy for yourself. That's going to be 56. So let's divide one more time. 7 and 8, or let's try 6. Yeah, let's just do 7 and 8. And then that's going to be 4 and 2. Alright, perfect. Square root of 4 is 2. Done there. So cross out this radical 4. We have a matching pair of radicals, radical 2, radical 2. So that's another 2. If you don't believe me, multiply them in your head. Radical 2 times radical 2 is radical 4. Square root of 4 is a nice 2. So done. So cross these out. We don't need those anymore. And we're just left over with this radical 7. So 4 radical 7 is what we get for y. Alright. And I think we're done. And that's about it. So that's the challenge. If they ask you to find the perimeter of this, then you would just add 4 radical 2 plus 4 radical 7 plus 12. You couldn't combine them because the radicals are not identical. These are kind of like x's. They have to be the same in order for you to add or subtract them. Since they're not the same, since one's a 2, one's a 7, you can't really actually add them. You could only write them as an expression. All right, good luck. Hopefully this worked out for you, and we'll see you tomorrow.